All right. What we have here is it's actually from a tuba, which is a musical instrument like a big trumpet, great big trumpet. And this is the cap where the button goes, and this particular cap here, the thread is worn on the inside here. Now, probably the tuba male thread that goes inside here is just as worn as this, but that's almost impossible to replace because it's so large. So what we're going to do is remake this cap here smaller with the thread here, just to go a little bit tighter on the tuba itself. Now, because this is English and old, it's about 100 years old, to make a couple of assumptions about what this thread is, and there happens to be a thread called microscope thread, which you can imagine is a very, very fine thread to make with very thin diameter pieces of tube. And we call it microscope thread because it's used a lot in microscopes. Now, microscope thread pitch is always 36. So we assume it's microscope thread and a 36. But we'll just check this here. So what I've done is I'm assuming it's microscope thread 36, and I looked up in Wikipedia, the oracle of all knowledge here when it comes to all sorts of information here, and we assume it's 36. So the big test is to grab a pitch gauge, this one here. It's imperial here, and that says 36 on here. And I've tried that in the thread in here, and basically the thread works out perfectly. So we assumed it was microscope thread. We checked it with the pitch gauge there, and it says it's 36 there. So it is microscope thread with a pitch of 36. Now, all microscope threads are the same pitch despite what the diameters are. So you just make the diameters to suit whatever it is, and the pitch is always the same, and the thread form is always the same. Now, on the cap itself, the problem is we've got these areas have been lopped off here, and there's not much room here, and consequently there's not enough thread to make up the difference here. So what I'm going to do is make a deliberately smaller cap in this diameter here, and cut my thread the regular size here, and just go a little bit more there, and hopefully these flats that are already here will be taken away in the new one. I can't fix the original because I can't put material back on. Now, the size I got was 31.8, so I'm going to deliberately make that a ½ mil smaller at 31.2, and hopefully that will fix our problem. The focus is not so good here at the moment. Where are we? There we go. So 31.2, and what I'll have to do is make up a male thread here because I don't have the tuba itself, and even if I did, I couldn't cut the thread and try the tuba in there with this particular thing screw cut here, because it would be just almost impossible. So what I'll do is I'll make up a dummy thread here in bronze, cut it what I think it should be, and of course then I'll once again my focus is gone, and basically make this to the size I think it should be, and then make this particular part here the new size. So and then I'll have something to try this out with. Okay, that's the plan. So I'm going to have to make this part, first of all, a male one of this first, and then we'll make the cap to suit that, and we'll try the thread in the lathe there as we cut it. Okay, so I'll just come up with the blank here. I'll machine that up there. There's a few diameters that are probably critical. Obviously, if that's the tuba, the button here, the hole there is critical, so I'll just measure that there. Now, this one also has a newel, a straight newel on the outside, but I've asked my friend who's doing this repair job here if he can get away with no newel at all, and he says that's okay rather than try and cut a newel on here. So all I have to do is reproduce this. I'll do it in bronze. This is probably brass here. And of course he'll get the thing silver plated in the end there so that it looks like the original one. And we should have a replacement one there, and once again breathe a bit of life into probably about 100-year-old instrument, and apparently it's worth around about $100,000, so it's definitely worth doing. Well, what I've done here is I've turned up a male version of the tuba. I've basically mimicked the tuba itself and came up, and I've sort of approximated what the overall diameter of this thing is going to be at the top of the thread here. And now I'm going to screw cut this diameter here with the 34mm pitch, and I'm just going to keep screw cutting until such time as I can get this cap here to screw on. Now the reason why I'm doing this is so I can make up so when I make my cap, I can deliberately make the diameter on the inside here smaller and just keep screw cutting that until the new cap screws on this, and I'm going to use this as its gauge. You'll probably see a little bit closer what I'm doing down the track here, but that's the plan. We're going to make a gauge out of this that screws onto that. Then we're going to make this again, 1/2 mil smaller on the minor diameter of the thread here, and keep screw cutting until that screws on there. Now what's happened is the thread is missing its peak on the top here, so we're missing this bit here, the little peak of the thread here. Okay, so we're going to make that deliberately small there, and hopefully that will correct our problem. Okay, and as I'm screw cutting, of course, I can use this now as my gauge and not the tuber itself, and I can keep screw cutting until the cap goes on. Well, that's the plan. I'll probably end up having to make another go at this. I think the chances of this actually working first time round is probably around about 50%. So we'll give it a go, and if they come back and say make it a little bit bigger, I'll make it a little bit bigger, and we'll just keep going until such time as we make one fit. And that's the plan. Okay, what I've done here is I've made up a cutting tool, a little V cutting tool here with the right pitch of the thread on here. Now this, unfortunately, this is a really long way out here, but because my brass is so small in the length here, I've had to thread this out to miss this part of the holder here. So it's out a long way here, but it'll probably be okay. We're only cutting a little bit of bronze anyway, and I'm going to screw cut this at the 36 pitch here. Now it looks like we're going to miss everything here, so we'll need to set our machine up for 36mm pitch. So we'll just come in here, we'll just shut this here, and I'll put this on the medium range here. Put this on the medium. Start the machine up. It's actually easier to change these machines whilst they're actually in gear. Now we're looking for here 36 on the pitch here, 36. Here we have 30, 20, 36. There it is there. Now that will be I, or 2, L, A, 6, no, L, A, S, 6. So we'll put this on to 2 down here, which put this into imperial, by the way. 2, that's on 2, that's on L anyway, so don't have to change that one. Now what is this again? It is, where are we? L, A, S and 6. So S down here, that is on S. A over here. Okay, that's on A. And 6 is down here. So that should be correct here for 36mm pitch. Come over here, we'll just check and make sure this is rotating. That's looking pretty good. And remember, we're only making the male here of a as a gauge, so we're not really that particular about this. We've just got to get the thing on and see how it goes anyway. So it'll be a bit of a dummy run here. So let's check a few more things out and we'll start screw cutting. So what I've done now is I've screw cut this down here, and I'm just trying this cap on here as I'm screw cutting down here with this thread here. Very fine thread, and the cap is just starting on there a little bit here, but it's still going a little bit too tight, and I don't want to stretch the thread here. I'm going to keep going until I just get that running on there snugly, and that way I'll have our gauge. I'll just keep going here. So at the moment we're down at 0.8 here. I'm just going to go down to another 0.1 here, and we're going to screw cut that a little bit deeper. So we'll run this thing forward here. Stop our machine, take our tool out a little bit, and we're at 0.9 at the moment. We'll run the machine back in reverse here. So we'll just come off a little bit here because I don't want to disengage my feeds here. Come away far enough. We're at 0.9 at the moment in our depth. We'll just stop that there, and we'll see if we can try this on here and see if we can get that on this time at 0.9. It's a very fine thread, so I want to be careful I don't do any damage here. Still a little bit too tight. I'm just going to keep going a bit deeper here. I'll just drop this out for the moment here. Alright, now I've got this on. It's going on snugly. It's still just a fraction too tight, and I want to just go a little bit more, and then I think we'll be ready to go with our gauge here. So it's just going on there a little bit snug, just a fraction too tight. We'll just take that off now. Right, now I have my male gauge for this, and that cap screws on there quite snugly. So whenever I make this cap now, it must screw onto this male piece, and that becomes my gauge. So that's there. Obviously that's not going to pop off very easily, so I'm going to basically machine up another one of these, but make sure our minor diameter here is a lot tighter when I do this here, and that should avert the problem there, and hopefully it'll work first time round. So now we're going to make the part proper for this tuba. We have our new piece of bronze this time, and we're going to turn the outside diameters, and once we've done face to front turned out, we're going to turn a little bit of a step on the front here, the front face here. We'll turn that, we'll turn this diameter along here, and then when we've completed that, we'll then part this off the back here, and that will fall free. And then we'll turn the part over and we'll do all the inside work here and cut our thread. Now we'll need to drill a hole through here. I checked this size here. There's an 8mm hole through here, and that's a ream size at 8mm. Oddly enough, the sizes look strangely metric, so it's kind of it looks like it's been made before. This is probably not the first time this has been done. So here we go. We'll face the front first, and then we'll turn our step. Over a little bit more. So now we're going to turn this first little step diameter here, then we'll drill our hole. So we've just got to machine this 14mm diameter 2mm long. So what we'll do is do our last cut here. And we'll wind this out the other way and clean up that face. That's looking pretty good. Now I'll have to take a few corners off here, but I'll do this diameter here next, and then we should be up and running. We'll drill our hole. So there's our second diameter here. This is 35mm in diameter, 14mm diameter here, and a 2mm step in here. Now I've turned this longer than the allowable length for this cap here because I need to part this off, and I'll need the width of the parting off tool to make it all work. Now I have to knock off these corners because they're going to be a little bit sharp, and I'll give this a polish before I part this because otherwise it'll look a bit rough when it's silver plated. So I've machined these diameters here, this one here, and I've polished this as well. It's always a good idea to polish as soon as you've finished machining something, because it's much easier to polish it now rather than try and do this after the fact. So now this is ready to part off, and I'll part this down here with our parting off tool, and this will fall free, and then we'll turn this over and we'll put it in some soft jaws here and on the chuck, and support that on the soft jaws. So now we're going to centre drill this particular hole here. We'll run our centre drill in. And that will establish our hole position. And then we'll change our drill over into the 7.5mm drill in. Just stop this a minute, get the noise down a little bit. We'll put a 7.5mm drill in the hole here, and then we'll run our 8mm reamer down through this, and we'll go around about the same depth as this step here, around about 10mm deep, so that when we part this off we don't end up losing this piece of bronze here with a drill hole all the way through it. So we'll just drill it and ream it, and then we're ready to part off. So we'll run our drill in 10mm deep. Possibly a little bit further than that. Line this out. And now for our reamer, we'll just take this away. And now for our reamer. So now we're going to ream this particular hole. It's always crucial to put cutting oil when we're using reamers, because they need to slide around the hole as they're cutting. So we'll just put a little bit of cutting oil on them, so that makes it a little bit better. We'll start this up quite slow this time, and we're going to run this reamer in to the bottom of the hole. A 7.5, then an 8mm reamer. And that should do it. Now I just have to chamfer this particular hole on the corner, otherwise we'll leave a sharp edge, and I'll just do that now. So now to part this particular part off. Now it's always easier to part into a hole that's already existing rather than part right to the centre of the part there. So I've drilled and reamed that hole on this side here now, and then I'll flip it over and do the boring from the other side here. But let's part this off. Now it should be free just to fall to the bottom of the machine. It doesn't, don't need to really catch this. It's not really going to damage it anyway if it falls to the bottom of the machine. And I'm just feeding this in by hand. Getting close to the end here now, and it'll fall down the bottom of the machine in a few seconds. So there's our two parts. That's our original, and this is the part I've just made. We're working on purely on the outside facing edges here. Now I still haven't cut this second diameter on this here, because I'll flip this over and hold this on that edge there, and we'll cut this second diameter here as we machine the inside faces. Now on the lathe itself, I'm going to put on some soft jaws on these jaws here. That's these ones. They're soft jaws, and I'll machine them to suit. The step on the part itself, so that when I hold this, it'll sit up against the little shoulder using soft jaws. Otherwise, I'll mark the outside of my part around here and damage it. So we'll just change our soft jaws over, and I'll have to machine them to suit the step on the part. Now we've set up the soft jaws on the chuck, and I have a boring bar that we're going to use to cut the step. Now I'm using a high-speed steel boring barb because I want a very sharp nose radius on the front, so that when I put my part in, this particular part, this is the original here, there's a radius on the corner, and I've got a sharper radius on the other one, and I don't want this to foul when we put it in up against the step. It's always nice to have soft jaws holding things like this, because then we can just put this in up against the face and hold it just on the edge, and the soft jaws won't damage the outside face. So we'll just machine this out to the right diameter, a little bit of a step, 2.5mm down, and the diameter of that particular part there. So now we've machined a step on here, so now we can put our part in against that shoulder there, and this little boss here clears in this area. It's always important when you're boring soft jaws to put a bung in the back here to load up these jaws, otherwise they flop around when you're machining them. So now we've got our soft jaws machined up, we can now take our bung out and put our part in, and of course then we can sit up against that shoulder, and that ensures squareness and a bunch of other things when we're machining. So I've machined this front face and got this to length, and I've also machined this little step that's in here, that just before the newel area. I'll copy exactly the same part, except that I won't put the newel on the back. Now we're ready to do the boring from the inside, and we'll get on with that now. So now we've bored this diameter here to 31.2, which is 1/2 mm smaller than the original size. So when we cut this thread, we'll end up with a smaller minor diameter here, and hopefully that will correct our problem with the existing Tuba cap. I'll need to just knock the corner off here, and also there's an undercut I have to do on the bottom of the thread, so as I screw cut my thread through here, I've got something to run out to at the back of the part here. Right, I've bored this section out, and I've modified my cutting tool here to make a 1.5 width grooving tool. Now I'm going to use that to cut a run out groove in the back of this diameter here, so that when I cut my thread in there, it will basically run into a groove rather than stop short. It's always a good idea to do a run out groove whenever you're cutting threads, because it makes it so much easier. So we're just going to open that out to 1.8, bigger than the diameter we've got. So now I have a run out groove cut back here. And now we're ready to screw cut the thread itself, the final part of this exercise. What I'll do is I'll modify this particular tool with the V on it, and we'll use that to cut our thread. So what I've done now is I've reground my tool with the V point on there for my screw cutting. Now, it's probably almost impossible to try and run the machine and cut this particular thread, because I've got to stop at the bottom of this hole here, and if I go too far, I'm just going to crush my tool. So what I'm going to do is I'm just going to cut this by hand by rotating the chuck by hand. I'm still screw cutting, but I'll just stop it by hand, rotate the thing, stop it, then wind the thing out, and keep going until such time as my gauge fits this particular hole here. So now that I've been screw cutting by hand for a little bit of while now here, I've got my gauge is just starting to start in that diameter there. So I need to keep going a little bit more, and I just want to keep going until this just screws in snugly. At the moment it's going a little bit too tight, and as soon as that fits in there, I'm going to stop, and hopefully we'll be on the right size. I'll just take this out for a second. It just screws out just a little bit snug in there, and we'll just run this forward a bit. Run this forward. I'm going to stop that now, And we're just going to take this out of gear and put this into neutral. Well, this is what I've been doing before, but it's a bit hard to hold the camera at the same time as show you what I'm doing. So what we'll do now is we'll put this in. I'll go in a couple of more divisions here on my dial. So we'll go another, say, a 0.1 of a millimetre here. And of course all I have to do now is wind this by hand, coming in here, just by hand, just spinning, just using my hand, and that will cut that thread. And you can hear it cutting shortly. And it's cutting now. And when I get to the bottom, I'm winding this down here until I see the 0 on this carriage here. Stop cutting now, we'll go to 0. Then we'll wind this dial to 1. Just remember where I am. I'm at the 0.1 position. We'll just take that out of the way and put this in reverse. Spin this back out again. And I'll do another finishing cut the same size I did before. So back over here onto the 0.1 on the dial. Just down to there. And of course I can wind that forward now, leaving my half nuts engaged, and now we're just doing a finishing cut. And of course we'll keep spinning that until such time as we end up at the 0 point there. Wind this back out again. Now it might be a good idea if I just zero this dial here. We'll just put that on to 0 so I know where I was, and we'll wind that back out of the way, and we'll run this in reverse. Now I want to get out a long way, and I don't want to disengage the half nuts because it's an imperial thread on a metric lathe. So we'll put this back into gear, into the low there, and pull this up, lever up here, making sure we're throwing it into reverse, otherwise I'll crash my machine. Put this down here. There we go. Pull that up there. And now we can wind that away until such time as we're far enough away that we can try our gauge one more time. And I may have to do this a couple of times to make it all work. And once I've got this ready to go, it'll be ready to try on the tuba, and hopefully it'll work. We should just fit that in there, getting close. Stop that for a second. Let the cover up, and we'll try our gauge one more time. Bit hard with only one hand. I'll have to drop this out for a second. We'll try it out. So I think that's my gauge fitting perfectly now. Now the last thing we have to check and make sure is our minor diameter bigger than the previous one? And we'll check that out now. So now we have our finished article. I checked this diameter across there, and it's about a ½ mil smaller in the minor diameter as its original, and yet it still screws on the gauge. So we've got substantially more of the thread form from this one here than we have on the original one, and I believe that will be fix our problem. So we'll see what happens. I'll give it to the customer and see what they say, and if it all fits, it's all well and good. But if it doesn't fit, more than likely it'll be easier just to make a whole new one, because it's very difficult to refine the thread with such a fine thread. And I think that should just about wrap up the project now. I'll just polish a few more things and clean up, and thanks for watching.